All right, so we're going to look at section 5.3, X-Intercepts and the quadratic formula, pages 94, 95, and 96 from your packet. Start up with a warm-up. Fast forward through parts of this if you understand it already. You don't need to go over through this example. You can fast forward. But I'm going to graph this, and I'm going to come up with an equation. So the vertex is at 4, -3. Okay, and the y-intercept is 5. Okay, so that tells me a little bit of information. I've got 0, 5. I've got 4, -3. I know that's the vertex, so I know it opens up. I know that my axis of symmetry is right here. So this point has a mirror image, a symmetric point right over here. That's going to be at 8, 5. Okay, from that I can draw it. I might want to put in a couple more points. Okay, let's write out our equation. We know that the general equation in vertex form is y equals a times x minus h squared plus k. Let's put in the vertex. This is h, this is k. So y equals a times x minus 4 quantity squared plus a -3. I could just say -3. Okay, now I can solve. Let's erase that a little better. I can solve for a by plugging in another point. Okay, the other point I can plug in this one, I can plug in this one. Let's plug in 0, 5. So I've got 5 equals a times 0 minus 4 quantity squared minus 3. Okay, so I've got 5 equals 16a. -4 squared is 16a minus 3. So I've got 16a equals 8. So a equals 1/2. And that seems to make sense. I was kind of looking at the way that this opens, and it looks like it's opening a little wider than usual. And it'll open wider than usual if your a value is less than 1. Okay, the magnitude's less than 1. So my equation is going to be y equals, and I'm going to plug the 1/2 back in up here, 1/2 and x minus 4 quantity squared minus 3. Okay, so what you can do here, you can make a table of values. There's a couple ways you can do it. You can make a table of values, x and y, and I can pick points near the vertex, so I can plug in 5 and see what my y is, okay? Or I could try to follow that pattern. So remember the pattern of over 1 up 1a, over 1 up 3a, over 1 up 5a. So let's try that. Our a value is 1/2. So over 1 up 1a, so 1/2. So that would get me to 5, -2.5. And over 1 up 1/2. Okay, that would get me to 3, -2.5, or -5/2. From there, I'm going to go over 1 up 3a. So that's going to be 3 1/2. So 1, 2, 3. That gets me to 6, -1. And then let's go over 1 up 5a, so 5/2, 1, 2, 3, 4, 5. That gets me to 6, 1.5, or 6, 3/2. Okay, and this looks like we're drawing a really nice parabola this way. Our symmetric point over here is going to be right there. So 2, -1. And this one, if I go 3 over, I'll be at 1, 3/2. And there's my nice parabola. Okay. Okay. Now we're going to introduce imaginary numbers here. 5.4, we're going to go into a lot more depth on complex numbers, imaginary numbers. But in order to do the next part, we have to talk about this at least a little bit. So what does I equal? I represents an imaginary number. So far, we've only dealt with real numbers. You've always learned that you cannot take a square root of a negative number. Well, that's not really true. You can take a square root of a negative number. You just don't get a real number. Okay, you get something that's called an imaginary number. And this thing I is actually equal to the square root of -1. So when you talk about complex numbers or imaginary numbers, you can simplify them, and the notation we use is I notation. So the square root of -1 is equal to I. So the way we would simplify these, I always just simplify these. If I see a negative under a radical, I break it apart. Square root of -1 times square root of 4. Okay. Square root of -1 is I. Square root of 4 is 2. So I times 2 or 2I. Okay. I always pull out the square root of -1. And then I have something left that I can simplify. Okay. Because I'll have a positive under the radical. So this breaks down into square root of -1 times square root of 20. Now I've got I rad 20. The rad 20 breaks down into rad 4 times rad 5. The reason I used rad 4, that's a perfect square. So that becomes a 2. 2I rad 5. That's the order you write it. You usually don't write the I after the radical. You usually don't write it before the constant. You put it kind of after, almost like it's a coefficient. Okay. This one, we'll have square root of -1 times square root of 32. So that's I times, this breaks down into square root of 16 times square root of 2. I use the 16 because that's a perfect square. That's 4 times I rad 2. And this one doesn't have an I, so we're just going to break that down. Square root of 36, that's a perfect square, times square root of 2, so 6 rad 2. Okay? Now, the quadratic formula by completing the square. I'm going to actually, I might need a little more space than this, so I'm going to do this on another sheet of paper. Okay, we know how to complete the square. You might remember what the quadratic formula is. Okay, but I'm going to take an equation. When you've got something like, let's say you've got something like, let's just do y equals ax squared plus bx plus c. We know that's an equation of a parabola. We don't know if it opens up or down. We don't know the a value. But if you want to find the x-intercepts, okay, you set this thing equal to 0. So we would say ax squared plus bx plus c is equal to 0. And then what we're going to get is our x-intercepts. That's why you often see this type of equation, and we use the quadratic formula to solve this equation, okay? But for our purposes, what we're going to do is we're going to complete the square. Okay, actually, I'm going to put the 0 on the left side. No, I'll leave it over here. That's fine. Okay, so what we typically do is we take the first two terms, the quadratic and the linear term, when we complete the square. Okay, and then I'm going to move the c over. Okay, now from these two terms, I factor out the coefficient of the quadratic term. I'm just going to factor an a out of both terms. You might say, well, you can't factor an a out of something that doesn't have an a. But you actually can, you just have to be a little creative. Okay, so if we factor an a out of something that's not there, we end up with an a on the bottom. Now let's just double check that when we multiply that out, that works. A times x squared gives me this. A times this thing will get AB over A. The A's will cancel, and you'll just get B times X, which is what we have. Okay. Now remember how we complete the square. We take this coefficient, B over A. We take 1/2 of it, 1/2 of B over A, which is B over 2A. And then we square it. So we get B squared over 4A squared. So B squared over 4A squared. Remember, A and B are just constants. They're the constants that you see in your quadratic equation. Okay? Now, since we added this, we either have to add it to the other side or we have to subtract it from the same side. Okay? But be careful, because we didn't just add this. We added this, which is in parentheses, which is being multiplied by this. So when we take this and multiply by this entire thing, one of the a's cancels. One of the a's goes away. So really, in effect, what we added was b squared over 4a. So I'm going to subtract b squared over 4a. So in effect, I really added 0 to the left side of the equation. Okay? And we completed the square here. So this should now be a perfect square. So I've got a times something squared and it should be x plus, and remember what this term is. It's half of this, or it's the square root of that, okay? It's really both of those things. Half of this would be b over 2a. Square root of this would be b over 2a. So b over 2a, okay? Then we get plus c minus b squared over 4a. I'm going to want to combine these, so let's get common denominators. This gets multiplied by 4a over 4a. Okay, so I've got a times x plus b over 2a squared plus, and now I've got 4ac over 4a minus b squared over 4a equal to 0. Let's move these two terms to the other side of the equation. I've got a times x plus b over a quantity squared equals, this one becomes positive, b squared over 4a minus 4ac over 4a. Okay, and we can combine those together into b squared minus 4ac over 4a equal to a times x plus b over a squared. Okay, let's divide both sides by a, or I'm going to multiply both sides by 1 over a, so that cancels, 1 over a. So I've got x plus b over a quantity squared equals b squared minus 4ac all over 4a squared. Multiply by that. Okay, now I have to square root both sides. Whoosh, whoosh. So I get x. This becomes plus or minus. Sorry, that doesn't become plus or minus. We'll make the other side plus or minus. So this, when we square root that just goes away. X plus b over a equals plus or minus the square root of b squared minus 4ac over 4a squared. Okay, starting to look familiar. Okay, so we've got x equals, let's subtract this to the other side, opposite of b over a. Actually, this should be, let's go back here. I lost the 2a. Sorry, x plus b over 2a. This should be a 2a. This should be a 2a. This should be a 2a. Nothing changed because that was inside of the square. So that should be a 2a. So when I bring it over here, it's opposite b over 2a, then plus or minus. This, we square at the top and square at the bottom since we're square rooting the whole fraction. B squared minus 4ac all over 2a. So x equals opposite b plus or minus square root b squared minus 4ac all over 2a. And that is your quadratic formula. Okay. So let's now, so that's what we would have here. Don't worry, you are not required to memorize this. I just think it's neat to see. And this is a formula. Maybe you've seen it before. Maybe you see where it came from before. I'm sure you've seen it before. But it's nice to know that it actually, now we know the math behind where this came from. So we were able to use completing the square to come up with that. Okay. And let's go to the next page. So solve the equation either by factoring or using the quadratic formula. Let's factor if we can factor. It's always easier to factor if you can factor, okay? So this one, got x, I think this factors, doesn't it? Two numbers that multiply to 15 add to 8, so plus 3 and plus 5. Yep, that looks like it works. So x equals -3 or -5. Use the zero product property. You set x plus 3 equal to 0. And here you use the zero product property, x plus 5 equal to 0. And you'd get these two answers. Okay. The next one, I don't think this factors. Two numbers that multiplied to 4 and add to -6. And that doesn't work. So we're going to have to use the quadratic formula. So x equals opposite of b, so +6, plus or minus square root of b squared, -6 squared minus 4ac over 2a, 2 times 1, that's just 2. So x equals 6 plus or minus the square root of 36 minus 4. We know A and C. Why did I write that in there? 4 times 1 times 4. Okay, so that's 36 minus 16 over 2. So x equals 6 plus or minus square root of 20 over 2. Square root of 20, let's simplify that. Square root of 20 breaks down to square root of 4 times square root of 5. So 2 rad 5. So we've got x equals 6 plus or minus 2 rad 5 all over 2. So we can divide these individually by 2 and simplify. X equals 3 plus or minus rad 5. Okay. Now, let's talk about the discriminant. You might have heard that word before, but the discriminant, we're actually not going to do this activity. I'm just going to talk about what a discriminant is. So the discriminant is defined as this thing that's underneath the square root. Okay. So for this one, our discriminant would be 20. The discriminant is defined as b squared minus 4ac. Let's talk about where that came from. When you're solving a quadratic equation, ax squared plus bx plus c is equal to 0, and you use the quadratic formula, this thing is called the discriminant. The discriminant is the thing that's under the square root. It does not include the square root sign. It's just what's under the square root. And that tells us a lot about our solution. So there's 4 different instances, 4 different things that can happen in terms of the kind or the types of solutions we get when we solve a quadratic equation. Okay, we could think about what happens if the discriminant is negative. If the discriminant is negative, you get a square root of a negative number. Okay, that's something that's not a real number. That's something that if we were to graph it, if we were to graph y equals, so what we're really doing here, if we're graphing y equals ax squared plus bx plus c, if we set this equal to 0, when you set the y equal to 0, you're solving for your x-intercepts. You're saying, where does my parabola cross the x-axis? Okay, and if you get a negative under the square root, you're saying there's no real numbers where that happens. Your graph might look something like this. Because when you have this equation, this graph, this parabola, and you set the y equal to 0 and you get no solution, okay, so this is the case where discriminant is negative. I'm going to say b squared minus 4ac is less than 0. You have 2 solutions, but they're 2 imaginary solutions. So we could say no real solutions, but 2 imaginary solutions. I'm just going to write 2 imaginary solutions. I think that's good enough. 2 imaginary solutions to this equation, or we could say zeros to this graph or this parabola, or solutions to this equation where we've set it equal to 0. Okay, so that's why sometimes we use solutions and zeros kind of interchangeably, but really there's solutions to this equation where we've set it equal to 0, but there's zeros to this graph. Okay, and our description would be, I'll just say b squared minus, we've got the graph. B squared minus 4ac is less than 0. And then we could have b squared minus 4ac is equal to 0. And think about what happens then. What happens if this thing under the square root is negative? I'm sorry, is it 0? Okay, then we have plus or minus 0. That means our x-intercept would simply be opposite b over 2a. And we would only have one solution, one real solution. Okay, so you might have something like y equals, let's say, x minus 2 quantities squared. Okay, then you have a parabola where the vertex is actually on your x-axis. Okay, so you've only got one real solution. We actually call that a double zero. We'll talk about that later, but it's one real solution that occurs twice, because when you solve this and you factor it, it actually occurs twice. Okay, and then you have your regular parabolas where b squared minus 4ac is greater than 0. And when this is greater than 0, you end up with plus or minus two different numbers. You get two real solutions. Okay? So you'll have two real zeros to the graph, two real solutions to this equation where you've set up an equation to solve for your zeros. And then finally, there's one more where your b squared minus 4ac is not only positive, but is a perfect square. So this happens in a case like, oh, let me move this down here. Okay, I'm going to actually give you an example for this one. And the example is, what if we had y equals 2x squared minus 5x minus 3. If I graph this parabola, what would be the nature or the type of my zeros? Or if I set this equal to 0, setting y equal to 0, I'm solving for my x-intercepts, okay? Which means I'm solving this equation, so the solutions to this equation. Okay, oh, my head got in the way. So x equals opposite of b, so 5 plus or minus the square root of b squared. So negative 5 squared minus 4 ac times 2 times negative 3 over 2a. So 2 times 2 over 4. Well, this thing in here is my discriminant. My discriminant, b squared minus 4ac, is equal to 25. And then we get 4 times 2 times 3, so that's 24, and there's two negatives, that becomes positive. Okay, so you get 49. You get a perfect square underneath your radical. Okay, so the discriminant is a perfect square, and when that happens, let's look what happens to your solutions. I'm going to come over here, 5 plus or minus the square root of 49 over 4. Now notice this goes away. So we've got 5 plus or minus 7 over 4, which means we have 5 plus 7 over 4, and we've got 5 minus 7 over 4. And because the radical goes away, these solutions, these zeros, are no longer irrational. They're rational. So we have two real, but we can be more descriptive this time, two real rational solutions to this equation where we're solving for our zeros. So 5 plus 7 is 12 over 4, so 3. 5 minus 7 is negative 2 over 4, so we get negative 1/2. Okay, so we've got a 0 here at 3. And we've got a 0 here at negative 1/2. Okay, our a value is 2. We know that this opens up. That means somewhere over here, we could figure out the vertex if we wanted to, but we know that this would open up. Let's see. And it's a weird distance apart, but it's going to be something like this. Oh, it's going to open pretty wide though, isn't it? Because that's a 2. So it's going to open probably something like this. And our y-intercept would be negative 3. So it's going to go through there. Okay. A parabola. I didn't do that so great, but we were really just focusing on these x-intercepts. Okay, so let's go to the next page. We're going to find the discriminant, and simply from the discriminant, we're going to figure out what types of solutions we have. Find the discriminant. The discriminant is b squared minus 4ac, which is b squared, so that's 1 squared minus 4 times 1 times 1. So 1 minus 4, negative 3. Types of solutions, well, there are two imaginary solutions. Okay. Let's go to this one. B squared minus 4ac. So negative 6 squared minus 4 times 1 times 3. So 36 minus 12, and we get 36, 24, okay? So that's not a perfect square. So the types of solutions are going to be two real solutions. They're not rational, but we know they'll be real. There will still be a plus or minus square root of 24, and square root of 24 is not a rational number, okay? Shortcut for finding the vertex quickly. Okay, so here's what we're going to do. We're going to find the vertex quickly. We can average the two x-intercepts. So let's think about this. If you've got something y equals ax squared plus bx plus c, there's your parabola. And if you want to find the vertex quickly, well, think about what you do. You find your x-intercepts, which means you set this equal to 0, ax squared plus bx plus c, and that's going to find your x-intercepts. Think about a parabola. If you know your two x-intercepts, let's say here and here, okay, you know that halfway between here is going to be your axis of symmetry, right? Even if you don't know where your vertex is, you don't even have to know if your parabola opens up or down. Either way, even if it opens down or if it opens up, the axis of symmetry is going to be halfway in between. So you can take these two values of your two x-intercepts and average them. Okay, I know you all know how to average two numbers. If you get an 80 on a test and a 90 on a test, you add them up, divide by 2, and that gives you your average, right? You add two numbers, divide by 2 to get the average. So we're going to add the two x-intercepts, divide by 2, and that's going to give us an x value. And that x value is going to be the x-coordinate of our vertex, okay? We don't know necessarily that it's going to be here, but it will be somewhere along the axis of symmetry. Okay, and we know that our x-intercepts are going to be opposite b plus or minus square root b squared minus 4ac all over 2a. So this is our first one, and this is our second one. Opposite b plus square root of b squared minus 4ac over 2a, and opposite b minus square root of b squared minus 4ac all over 2a. Okay. Now, if we average the two, so opposite of b plus square root of b squared minus 4ac all over 2a plus opposite of b minus square root of b squared minus 4ac all over 2a, and then divide by 2. Okay. Well, adding these together, let's just add the top together. Let's just take this and this. They already have common denominators, so it's over 2a. We've got opposite b plus this plus opposite b minus this. These two cancel. Okay. And then you've got opposite 2b over 2a, and we'll divide by 2, which is the same as, well, those 2's cancel. So opposite b over a divided by 2, which we could write as opposite b over a times 1/2. And we get opposite of b over 2a. If you think about it, that kind of makes sense when you look at this. Okay. You've got your x value, and you're adding and subtracting the same distance from the opposite of b over 2a to go to the right and to the left of the x value of your vertex. Okay, so let's use this. From this, we're going to find the vertex quickly in these three parabolas. So opposite the x coordinate of your vertex, or your h, is equal to opposite of b over 2a, which is equal to opposite 4 over 2 times 1, or negative 2. So our vertex is 2 comma something. Now, how do we find the y? Well, you just want to find the y value that corresponds to this x value. So the y value is going to be, plug in the negative 2 for x, so negative 2 squared plus 4 times negative 2 plus 3. So y is going to be equal to 4 minus 8 plus 3. That's going to be negative 4 plus 3, which is negative 1. And look at how quickly we found that vertex. Okay, I'll do these two. If you get it, you don't need to watch. Okay, but we're going to do just a couple more. So opposite x corner of the vertex, or the h, is opposite b over 2a. 2 times negative 2 is negative 4, so I get a positive 2. Okay, so my vertex is positive 2 comma something. My y is going to equal negative 2 times, plug in a 2 for x to find the y that goes with it. So 2 squared, 4 plus 8 times 2 minus 7. So negative 8 plus 16 minus 7. That gives me positive 8 minus 7 gives me 1. Okay, let's do one last one. H, or the x coordinate of my vertex, is opposite b, 7 over 2 times a, 6. Okay, so my vertex is 7 over 6. Oh, this one might get messy. Okay, so we've got the y value, which equals 3 times this thing squared, so 49 over 36, minus 7 times 7 over 6, plus 2. Okay, so this we can reduce. The 4 and the 36 reduces to 1 and 12. So we've got 49 over 12 minus 49 over 6 plus 2. Okay, let's get common denominator. So 49 over 12 minus 98 over 12. So we have to multiply by 2, plus 24 over 12. Okay, so that gives me 49, negative 49 over 12 plus 24 over 12, which gives me negative 25 over 12. I think that's right. And I know that's a pain in the neck, but yeah, that's what you would have to do. Okay. And I think that's all for this section. I know that was long, but that's all for this. One thing I just wanted to say, this should have been a negative 2 right over here. Okay. I know we had a negative 2 here, and then I wrote a positive 2 here. That should be negative 2. And that's it.